Hello, and welcome to Big Data 2.0 IoT as your new operational data source. The Internet of Things is more than just smart and connected devices. The amount and type of data they collect can truly transform your business and operations. But only if you make that data accessible. In this presentation, we will see how you can integrate IoT in your analytics landscape. My name is Christopher Manno. I'm a senior cloud advocate at Microsoft, focusing on IoT solutions. If you're in a hurry or want to share a quick version of this presentation, do not hesitate to visit this link to access the short version of this talk. However, if you want to see how to operationalize your IoT data through demos, continue watching. Deploying and connecting thousands of IoT devices comes with a price tag. Organizations doing it expect to get some value out of it. In IoT solutions, most of the value is brought from two components. First, the digital twin. It's a digital representation of the actual product. Through the life of the IoT system, this representation can be rearranged to solve various problems. If you want to learn more about this, I encourage you to check out other sessions within this learning path. Value of IoT deployments is largely provided by the analytics we can power from IoT data. Analyzing that data and making sense of it by converting it into useful information is critical to the success of any IoT project. If you don't have any previous analytics experience, we got you covered. In this presentation, we will start by quickly introducing the challenges of big data and the kind of data IoT system produce. Then, we will talk about the challenges of ingesting and storing IoT data and why it can fit your existing data estate. Then, we'll see why using IoT as an operational data source for your analytical system can unlock insights and actions across the organization. Let's start with a primer on big data analytics and data management. Let's have a look at the variety of data IoT systems can generate. First, IoT generates telemetry data. We mainly have JSON documents, even if from time to time we encounter a lot of other data formats, including column-encoded ones. Then, we will get all the metadata associated with data itself, the IoT device or the system. These values may change slowly over time. These metadata can also be precious sources of information for your analytics. They can also be enriched in the process with reference data or other sources. The diversity of IoT-generated data can be immense, image and video streams, but also many other formats. IoT gateways like Azure IoT Hub facilitates file upload from IoT devices, enabling the collection of all kinds of unstructured data. When working with data, one of the first questions we have to solve is where to store it. I presume you're all already familiar with operational databases. These relational databases powers most of the business applications out there. The way they are designed allows software developers to efficiently do a lot of writes and micro-reads while a user is interacting with the business application. While these databases work well for application, they are not suited for analytical workloads. That's why we encounter other kinds of databases, like, for example, a SQL data warehouse, where we model the data for analysis and reporting, using several techniques like denormalization. Let's see an example of what's different between an operational database and an analytical database. Here you have an order table. Let's see an example of what's different between an operational database and an analytical database. Here you have an order table from a commerce application. Each order has only one line, and that line is updated when the order status changes. Now, let's have a look at the analytical counterpart. Even if we have an order table, things are quite different. First, we have new tables, dim customer and dim date. This table will allow data analysts to explore data, not only older ones, across different axes or dimensions. Then, if we have a closer look at our analytical order table, we can spot that one of the orders has multiple rows. The way these database structures will allow to capture historical data. Doing so, data analysts can easily answer questions like, who are the customers mostly affected by shipping delays? Analytics of the past is a common scenario in the IoT space. If you want to predict future events, this historical data is a foundation to most of the machine learning work you may want to start. In order to move data from operational database to analytical database, we tend to use a process called ETL, extract, transform, and load. There is a lot of technical solution to this, from SQL Server integration services to Azure Data Factory, or even using custom scripts. This process is mainly done in batch mode during the night. This process can be quite simple, just executing a bunch of select queries on your store and inserting the result in the analytical database, or can be quite complex with a lot of transformations and lookups. Usually speaking, big data refers to a system that produces so much diverse quantity of data that traditional BI systems cannot analyze it. We define big data systems with three adjectives called the three V's. First, volume. It's simply the amount of data stored to be analyzed. IoT solution produce a high volume of data. Then, variety. Is this changing and unstructured nature of the data to be analyzed? As opposed to relational data, where all the data is well organized in table format, big data systems can analyze semi-structured data like JSON documents or unstructured data like image and video files. The wide range of IoT devices existing can produce an equally wide range of data. And at last, velocity, which is the frequency to which your system will generate data. In the IoT space, it can be as low as a metric per hour, up to several data points per second. As we saw earlier, most of the analytical databases are data warehouse databases. These databases can be deployed on one and only server, either physical or virtual. That means that your analytical power is bounded by the limit of these server resources, mainly compute, memory, and storage. Over time, you will have more historical data to dig in. You will ingest data at a higher pace, and maybe you will also have more data analysts that want to dig into this data. When you reach that certain point, the only option you have is to grow that server. Even if it should be easier if the server is a virtual one, we all know that you cannot grow that kind of server indefinitely. With the increasing data velocity, we had to come up with another architecture, the big data architecture. In big data systems, we are using a specific architecture. The first component is a shared storage. Doubling the spec of server can cost more than double of the cost. That's why instead of using one very high-end server, we use several commodity servers, grouped as a cluster, and we will distribute the workload across them. For ensuring coordination between these nodes, we need a control node. When you connect your analytical tool to your big data cluster, you're usually opening a connection to this control node. This node will parse your query, distribute the work among the computer nodes, and aggregate the results before sending them back to you. In the future, if you need more power, we can simply add more compute nodes to your clusters. On the opposite side of things, some big data systems allow you to reduce the amount of nodes if you have less analytical work to do. That's the case of solutions like Azure Hosted Hadoop, HG Insight, or Azure Synapse Analytics, or newest analytics solution. There is multiple ways to store and process data for your analytical needs. Whenever you're using a data warehouse or big data systems, we can land your IoT data in your data landscape. Through the rest of this presentation, we will see different ways to achieve this. When you start thinking about how to do it, two questions emerges. In most IoT architectures, IoT data goes through a central point, an IoT gateway like Azure IoT Hub, that can dispatch incoming states and telemetry to downstream storages. The first question you may ask yourself is where we can store our IoT data. Then your IoT data will probably need to be refined and structured in a specific way so you can run your analytics on it. Therefore, you will need a place to process this IoT data. We've seen why IoT and big data share the same challenges about the type of data they handle. We will now see why integrating IoT data as your new operational database is facilitated by Azure solutions. There is three main challenges regarding data ingestion. First, we need to prepare the data so the analytics can find and use it. Then, we will need to aggregate data to the right level. Having a millisecond resolution on temperature sensor can be useful, but if you're just monitoring your house operator, it may not be the right fit. And then, we may have to duplicate data to different and specialized storage analytics systems to unlock specific analytics scenarios. Now let's have a look at this simple IoT architecture. On the left, we find our IoT gateway. On the right, our analytics and reporting tool, PowerBI. Along this presentation, we will build upon this simple architecture by adding services and features. Let's start with the raw storage. We will store all incoming telemetry data in its raw format directly into Data Lake. This data will unlock all analytics and machine learning scenarios we may arise in the future. On the other side, data analytics wants harmonized data, a cook meal if you want. That's why this data will also be processed and ingested into an analytical data store, here a data warehouse. For doing this, we will use Azure Stream Analytics service. As you will see in the next demo, with Stream Analytics, you can easily process and store data into several data sources, including SQL Data Warehouse, without having to deploy any complex service. In very specific cases, some IoT data can also be stored in a classical SQL database. This is also something you can achieve with Stream Analytics. Because cooked data often loses the golden nuggets data scientists are looking for, our current architecture, storing both raw and prepared data, enables a wide spectrum of analytical needs. In this demo, we will see how you can easily ingest IoT data into a data lake and process it so it can be stored in a data warehouse. Now we will see how you can output all your incoming IoT messages to the data lake. Actually, this is a feature directly embedded within IoT Hub. For doing this, you go to the portal and then you will scroll down to message routing. And actually what you will see here is you can add custom endpoints. So you can directly from IoT Hub send all the incoming messages to several destinations, including event hubs, subsbus queue and topics, and storage. So we'll go there and click add and select storage. Then we will need to add an endpoint. Let's say data lake endpoint. And then we need to pick a container into an existing Azure storage account. So you can actually output your messages to a classical storage account or to a data lake. For this demo, we will choose data lake here, and I will create a new container, IoT raw data, and go ahead and click on create. And then select my newly created Azure container. Now you have several settings. The first one is around the batch frequency and the chunk size window. So actually IoT Hub will have a little buffer for all the incoming messages, and either when the batch frequency is rich or when the chunk window, so the maximum size of file to output is rich, then IoT Hub will actually write to the data lake. So I will leave these settings by default and going on. Next setting is the encoding. IoT Hub can create two type of files within your data lake. The first one is a JSON file format, which is easy to manipulate with a lot of different services and even your own code. And the second one is Azure, which is a specific format we widely use in the big data environments alongside with the Parquet format. And the latest thing we need to set up is the file name format. If you want to actually change the way your file are organized within your data lake, you can do it so there. So I will go get select JSON and click create. The custom endpoint is now created, but I actually need to do an extra step for forwarding all my events to the data lake. For this, I need to go back to the routes tab, and it's clearly indicated that you actually need to add a route to actually direct all your messages to your newly created custom endpoint. So I will do this by clicking add, type a name to data lake, selecting an existing endpoint, and you can see I can find my new custom endpoint here and the data source. So what kind of data I want to actually store within my data lake. By default, I will select the device telemetry messages, which is all the messages sent from the device to IoT Hub. But actually you can also, if you need, output the device lifecycle events. So everything happening about the lifecycle of the IoT device, you can also analyze them if you want. And I will ensure that select enable the route, so the route will be active as soon as I click save. And one of the cool things also is you can also have a routing query, which means that you can actually decide on specific criteria, like the type of devices or the customer where the device is set up, if you want to route these messages to this specific endpoint. For the demo, I will just let true value here, so I can send all the messages to my custom endpoint. And I will just have to click save, and the route is added. We just saw how you can easily store all the incoming IoT data within the data lake. Now we will see how you can store the same data within a data warehouse. But before that, we need to take into account one thing, which is volumetry. IoT app can output several events per second, and this number can grow depending on the type of IoT devices and also the number of IoT devices. However, you don't want to store all these events within your data warehouse. You can definitely overload it within minutes. What we want most of the time is an aggregated view of this data within your data warehouse. We will see how you can use Azure Stream Analytics to store aggregated data directly from IoT Hub into your existing data warehouse. We are back in the Azure portal on a Stream Analytics job. For creating a Stream Analytics job, you will need at least 3 different things. The first thing is an input. It's basically where you can get your streaming data. But as you can see here, I've added another kind of data, reference data. And we will see why I'm using 2 different sources of data within the Stream Analytics job. So next thing you will need is an output. Here, I have already created a data warehouse output. And last but not least, your query. It's basically a SQL query that allows you to aggregate your data from your different sources and then output them into your output. As you can see here, you can easily see the preview data from your different inputs, but also test your query on real data or on sample data you can upload directly into the portal. In this specific query, I'm doing very simple things. I'm averaging my sensor data, and I'm also combining my actual sensor data to a device reference data. That is a common scenario where within the IoT app, the message you receive just contains a technical ID, and within your data warehouse, you actually need to know that the sensor is actually set up in this specific room on this specific building. And that's exactly why I'm doing this with basically a join between the raw data from the IoT app and my reference table within an actual SQL database. The last thing I'm doing here is using the stream analytics windowing functions to actually aggregate all this incoming data over a period of 2 minutes. So I will only add one entry in the data warehouse every 2 minutes. We just saw that integrating IoT data into your data analytics landscape is possible. Now, let's see some concrete examples on how to get insights and actions from your IoT data. One of the most straightforward ways to use your IoT data is by augmenting existing dashboard with them. There you can see a PowerBI report made by the IT department of Contoso City. On top of several traditional data, you now have at the bottom of your report new data coming directly from an air quality IoT deployments. Let's dig into how this report is created. The IoT data comes from two distinct data sources. Air quality alerts are stored in an Azure SQL database from a Stream Analytics jobs. This job will only output a new line in the Azure SQL database when one of the sensor values go above a threshold value. The graph at the bottom right is a bit different. It's a graph of the sensor readings with an interval of 5 minutes. Here, all the processing is actually done in time series insights. We are just exposing this data within PowerBI. And as you can see, you can have other classic data sources from a PowerBI reports, like here a PostgreSQL database. In this demo, we will see how you can use IoT data in PowerBI to unlock new insights. When your IoT data is already ingested in your data warehouse, displaying this information within PowerBI is very easy. You just need to click there on Get Data and select SQL Server, and then type the name of your server and the name of the data warehouse. By clicking OK, PowerBI will actually connect to your data warehouse, and then you can see all the table and load this information onto PowerBI. I've already done this previously in this demo, so I've already loaded the air quality measurement from my data warehouse and display the information in the graph on the left lower part of the screen. And I've also connected to another data source, simple SQL data source from business software managing the room occupancy. So as you can see in this graph, I have the room occupancy for a specific room and also the air quality from a specific room. If we look at the room occupancy, the data seems to be expected. We have no occupancy at all during the evening and the night, and we have normal occupancy during the day, even if Wednesday seems to be a high occupancy day. if we look at the air quality graph, again, we see a pattern that we should expect, which is lower air quality during the day than during the night. And again, on Wednesday, a bit high CO2 level. But one of the great things you can extract from IoT data is insights. And with tools like PowerBI, you can actually correlate your existing operational data with IoT data to uncover new insights. Let's try to do this with these two data. I will first add a new graph here, where I will first add again the data from the IoT system. So I will use the date and display the CO2 on this graph. So it's basically the same one than this one. Now what I will do is I will add on the same graph the room occupancy data coming from my operational database and see what happens. So I will go on room occupancy and drag this on secondary values. Now I have the two graphs together. I can see some interesting patterns. As you can see, we should expect that during the night, where the occupancy is 0, the CO2 level should decline, but it's actually increasing on Tuesday evening. Another pattern we can see is after Wednesday, on Wednesday evening, we should see a decrease in the CO2 level, but actually is a bit increasing. These patterns could not be identified if we look at the IoT data and your existing operational data separately. But because we've added these two data together, we can uncover some insights. And here maybe we need to go check out that room, and maybe there is an issue with the air recycling system. Now in this architecture, all our reporting is based on structured data ingested all day long via Azure Stream Analytics. In some architectures, we also see this processing happening in batch mode once a day. You can implement this ETL process from raw data stored in the data lake with tools like Azure Data Factory or the data flow features of Synapse Analytics. Data stored within the data lake can be organized. In big data scenarios, you can also use this architecture to refine raw data into a more structured and enriched form, also stored in the data lake. In this demo, we will see how you can easily query historical data with Azure Synapse Analytics. Let's go back to our air quality scenario. We saw in the first demo that our data is stored into two storages. Raw data is stored as is within the data lake, and hourly aggregated data is stored in the data warehouse. Now, imagine the air quality standards are about to change. From an hourly average maximum value, we're switching to a single measurement maximum value. And that threshold value is changing as well. So we will need to use that raw data stored in the data lake to answer that question. However, the data is unstructured in a form of folder hierarchy with JSON files. We will see how we can use Azure Stream Analytics to easily tap into that raw data. Let's jump into the Azure Synapse Analytics workplace. From there, you can simply create a SQL script where you can actually tap into data stored directly within your data lake. With this first query, I'm just reading the bunch of JSON files and getting the raw data as one document per line. Here you don't see it, but I'm actually tapping into a huge number of directories. But this data is still unstructured. So I can start using some JSON parsing features of the SQL language. So I can easily process these JSON files and actually get a nice table formatted system. From there, I can easily build a query where I can actually do my filtering like what I'm doing here. And as you can see, within seconds, I'm able to execute a query on a huge number of servers, tapping into all the historical data I have within my data lake and within seconds. Here in this demonstration, I'm using the SQL on-demand offering, which means that I'm not processing or provisioning any specific hardware before executing my query. I will basically be built for this query itself. That's why it may take a little bit time to actually execute that query. But if you have the same amount of usage and you need the same amount of throughput, you can actually provision your own SQL clusters within Synapse Analytics. Here, you can see that my new threshold have been only crossed 3 times in the past year on 2 different devices. We just saw that Azure Synapse Analytics can process raw data from a data lake easily, but it can also be used to store data. In fact, all the demos you've seen so far don't use Azure SQL Data Warehouse, but are using Synapse Analytics under the hood. Using it within your architectures can allow you to reuse your existing data warehouse skill sets and applying them to a whole new level. Data engineers are mostly asked to work on historical data. With PowerBI and Azure, they can also easily work on real-time analytics. By using Stream Analytics, you can process, aggregate, and filter data coming from IoT Hub in real time and outputting this data to several destinations. For example, you can use the streaming data tile within an Azure dashboard to display this data in real time. No code, no background service, you just have to write a SQL query. In this demo, we will see how we can create a real-time dashboard with PowerBI. In order to create a real-time data source for PowerBI, we actually need to jump back to the Azure portal within your Stream Analytics job and go ahead and create a new output. When you click on the Output tab, you can actually add several outputs to the same existing job. And here we can select PowerBI. The first thing we need to do is to actually authorize your Azure subscription to access your PowerBI workspace. Once connected, you need to set up an output alias that you will use within your query. For example, here, PowerBI. Then you will need to set up a dataset name. We can say real-time IoT and a table name. Then click on Save. To actually see this new data source within PowerBI, you will first need to start your Stream Analytics job. Now, let's switch to PowerBI. Go to your workspace and on New, click Dashboard. Type a dashboard name like real-time air quality. Within the dashboard editor, you can click on Edit, Add a tile, and scroll down to go to Custom Streaming Data. Click on Next, and then you will see the new dataset here configured within Azure Stream Analytics Live IoT Data. I double click on it, click Next. Now I will customize the visualization. I will leave the default visualization type, card, and I will add a field value here. As you can see, I can get all my output columns from my SQL query. And for example, here I will output the average ozone value. I'm click on next, leaving the title here, and click on apply. And as you can see, every 5 seconds the value, average zone value will actually change, hopefully. Yes, we can see that this value has changed. It's not almost real time because within the Azure Stream Analytics query, we used a windowing function with an output every 5 seconds. This allows us to get almost real near-time data outputted within PowerBI. Azure Stream Analytics can process your IoT data in real time, both for your analytics store, but also for real-time dashboard needs. But why limiting yourself to crunching and displaying data? When you know how to use Stream Analytics, you're a step away from executing your code, or even better, a workflow. Here, the same Azure Stream Analytics jobs is also launching the execution of an Azure Logic app, a no-code, serverless workflow service within Azure, allowing me to execute actions in a wide range of applications, like sending a message in a specific channel in Teams. In this demo, we will see how to start real-time actions with Azure Stream Analytics and Logic app. To send real-time updates to Microsoft Teams, we will actually use 2 Azure products. The first one is Azure Stream Analytics that we saw in a previous demo, and we will use this product to actually get the data from the IoT Hub and then launch new workflow execution within Logic app. And the second is Logic app. Let's start with Stream Analytics. I've created a simple job with one input, the stream data from the IoT Hub, and one output. There is no Logic app output, so I've been using here a service bus queue between my Stream Analytics and my Logic app. And then a simple query, getting all the data from the IoT Hub, creating an average, maximum value and minimum value over a 2 minutes time window, and then answering I have some criteria here, a hard-coded average, maximum ozone threshold. However, as we saw in the first demo, I could have used reference data and then having this threshold to be a bit more dynamic. Let's switch to Logic App Designer. I've just created a brand new Logic app, and what we can do here is start with trigger, in my case a new message received in a service bus queue. I will have to connect to one of the service bus queue. We found out the alerts human queue, and I will check every minute for a new message. When I've done this, I can add a new step to process this message. And actually, Logic App Designer can connect to a huge number of online services. You can search from them directly here. And as I've already used the Microsoft Teams connector in the past, it's showing up here in the recent connectors. So let's go ahead and click on Microsoft Teams. Here you can see a list of actions you can take within Microsoft Teams directly from Logic Apps. There is a ton of ways to send a message. In our case, we will post what we called an adaptive card, which is basically a way to send rich graphic information as a card directly within a Teams conversation. And I will go ahead and select post your own adaptive card as a flowbot to a channel. I can now pick my team and then select a channel. Here I've created a dedicated channel for these incoming alerts, and I will be able now to add a new parameter to actually output the message. And here I will copy paste the content of the adaptive card, which is basically a JSON file. I can now replace some values with values coming directly from the incoming message, and I can click ahead and click save, and my logic app is ready. Now we can switch to Microsoft Teams and see our alerts coming in real time. As you can see, you can personalize all the display of the card, and you can display any information you want. We now have a complete IoT architecture analytics solutions. As you can see, we've added several services like time series insights to analyze timestamp data, but also heavily use Azure Stream Analytics to both enable real-time analytics and actions within Power BI and Microsoft Teams, and also historical data warehouse with Azure Synapse Analytics. Actually, when you have this kind of architecture with a hot pass managing real-time messaging and alerts, and a cold pass enabling historical analysis, this is what we call a Lambda architecture. You can find more information about the Lambda architecture on the documentation linked at the end of this presentation. What we saw today in this presentation regarding analytics is only a tip of the iceberg. You can also, when you're doing IoT, doing some analytics at the edge. Thanks to Azure SQL Edge, which is a low power version of SQL Azure, and Edge Streaming Analytics, which is a low power version of Azure Stream Analytics, you can actually enable a wide range of analytical scenario, both in the cloud and at the edge. For links to the relevant documentation, resources, and demo used in this presentation, check out aka.ms/IoT40/resources. If you are interested in this video recording, the materials can be found on github.com at aka.ms/IoT40. If you enjoyed this session and are interested in other topics covered in the IoT Learning Path, you can find them all at aka.ms/IoTLP. We covered quite a few topics in this session, and would like to remind that we have created a collection of modules on Microsoft Learn platform which pertain to the topics in this session. This allows you to interactively learn how to implement Lambda architecture for IoT Hub, create and use data warehouse with Azure Synapse Analytics, or how to explore and analyze timestamp data with time series insights. Go check out this collection on aka.ms/IoT40/learn. This presentation and the associated Learn modules can help guide you on a path to official certification. If you're interested in obtaining accreditation that can help you stand out as a certified Microsoft Azure IoT developer, we recommend checking it out on the AZ220 certification. You can find details on topic covered and schedule an exam today at aka.ms/IoT40/certification. You can also find related data analytics and data management certification on Microsoft Learn. Thank you again for attending this session. Cheers.